All right, so this video is for the fourth rule in our chart, which is going to be to deal with fractions or quotients or division of two functions. So the last video we talked about how to do multiplication, and so we got this rule number 3 on the right there, which is the so-called product rule, which lets us say if you've got one function times another function, then here's how you do the derivative. And the wonderful thing about this, which will also be true about the rule for this lecture, is that the answer really just contains 4 pieces. 2 of them are the original 2 pieces of whatever you had here and here. And then the other 2 are just the derivatives of those 2. So really all you really need to do the product rule is identify f and g, and then be able to compute the derivatives over here, which then could be used to just assemble this, I guess, foursome, right, of things on the right here. And so it's pretty simple. It's really just a question of a little bit of bookkeeping, and then 2 hopefully easy derivatives, namely what's the derivative of f and what's the derivative of g, and that's the only time that you'd actually ever need anything, over here, or, above, right? You might use one of these other rules along the way somewhere, but so similar good news exists for what happens if I want to do a fraction, right, or the division of 2 functions. It's a similar idea as the product rule. It's unfortunately just a little bit longer, I guess, right? There's just more pieces. So, all right, so on to that. That's what our topic is for today, which is the quotient rule, right, or how to deal with division. So that's rule number 4, the so-called quotient rule. Okay, and this is designed to let us be able to do the derivative of something that looks like a fraction, right, or the division of 2 functions. So just to have an example in front of us the whole time, it says maybe something like x squared divided by e to the x is a perfectly good example of a quotient, right, or a fraction. And the question is, as it's been all along, what is the derivative of this? Okay, and just like before, I know what the derivative of x squared is, and I know what the derivative of e to the x is. However, once again, don't do it. It's tempting, I know, but don't just tell me the answer is, oh, I do the derivative of the top, which is 2x, and the derivative of the bottom, which is e to the x, and I divide, and that's my answer. Okay, immediate, 0 points for that problem, because that's not, you don't have a rule that tells you if you have a fraction or division, right, division of 2 functions, it doesn't say you're allowed to just do them separately and then divide. Okay, so just like with the product rule from the last video, we needed a special rule, right? We needed a special thing that let us say, oh, okay, if you've got one function times another function, here's a way for you to legally do the derivative, which isn't that hard. Similar here, we have a rule that says if you have the quotient, right, or a fraction of 2 functions, here's a way of doing the derivative legally that, again, isn't too hard. So just like with the product rule, again, yes, there is a proof of why this works. This one's even worse. I mean, this is pretty awful. So I'm going to just tell you what the rule is, and then let's get comfortable using it. So the quotient rule, I'll write it kind of down here. And I'll add it to our chart when we're done with this video, says to do the following. So if you have one function divided by another function, so f and g are 2 friends, are back, but now instead of being multiplied, they're divided. So f divided by g. And if I want to do that derivative, here's how you would do it. So I would take the guy on the bottom times the derivative of the guy on the top, and now I'm going to subtract the guy, I guess it doesn't really matter what order I put this in. I'll put the top times the derivative of the bottom. And the thing that's especially not great about the quotient rule is that there is a denominator, which is the bottom, the old bottom, g squared. Okay, so it's not my favorite, and it's not going to be your favorite rule either. In that, it's a little bit of a mess. There's sort of a lot of stuff there to be just very informal. So okay, it is what it is. But let's try to be optimists and look at the bright side. So when I want to use this rule, what do I need? Well, I'm going to start with some fraction. That's going to be my question, which is going to have some top and some bottom. And I'm going to call the top f, or f of x, and I'm going to call the bottom g of x. Well, just like before, I could probably sort of write those down, right? And say, oh, okay, that's f of x, and g of x is blah. And the good news is, again, it's pretty much a no-brainer, right? Then whatever you see in the top of the fraction, that's f of x. And whatever you see in the bottom of the fraction, that's g of x. So, it's pretty hard to get that wrong, I think. All right, and then what is it that I'm going to need in order to assemble my answer? Well, the answer contains, if you look at the quotient here, this big guy here in the middle, it contains 5 things. But actually, what does it actually contain? It contains f of x. Well, I got that already. It contains g of x in 2 places, but I already know that as well. So what is the only new thing I need in order to fill in my answer is I'm going to need to know the derivative of f and the derivative of g. Well, this sounds pretty familiar, right? This is just like I did for the product rule. Maybe when I get myself set up, I should write down the derivative of each of these 2 guys. And then once I have my 4 pieces over here, that's all I need in order to formulate my answer. It's just the answer is going to look a little bit worse, but so be it. All right, so this isn't much harder than the product rule. It really isn't. So I'm just going to, before I do this example up top here for you, let me just give you an ultra word of caution, which you're going to have this in front of you, when you do your exams and things, but just be careful. It matters which order you put things in because I'm doing subtraction, right? The quotient rule, sorry, let me clear this out a little bit. Unlike the product rule, where it actually didn't matter what order you put, which you put first and which you put second, the product rule had plus, had addition here. This has subtraction. Now, so it makes a difference whether I put these guys and then these guys versus swapping those 2. You're going to get the wrong answer if you swap them. So just my only word of caution here is just be careful that you put this in the right order. And I should also say, just from having taught this course many times, don't forget the bottom. So I guess it's kind of easy to kind of be so fixated on making sure the numerator is right that you either completely neglect the bottom or you put the wrong thing in the bottom. So the bottom is whatever was on the old bottom, but squared. Okay? So, all right, so let's see if we can do this for this one up top here. So I'm going to get this set up just like I did before. I'm going to do my little setup thing. So let's see. So f of x, I'm going to come over here. So this is pretty easy. F and g are just the top and the bottom of the fraction. So f of x has to be x squared because that's the top, and g of x has to be e to the x because that's the bottom. All right, and then again, since I know I need them later, let me do the derivatives. And these are both in my chart. The derivative of x squared is 2x, and the derivative of e to the x is my favorite. It's just e to the x. All right, so I think I have the 4 pieces ready to go. And so now let me assemble this, which is the answer to my question, right? What is the derivative of this fraction? Well, there it is. It's that. So let me just be ever so careful with how I write down my answer here. So here comes my answer. The derivative of this quotient, this fraction, is the following. So I should do g of x, that's g of x, times f prime, that's f prime, minus f of x, that's x squared, times g prime, which is e to the x. And then don't forget, this is all divided by g squared. Okay, so that's that's the fill-in, I guess, right? That's the complete fill-in of my rule here with all my little checks there. So what, I guess, I don't know what else to say or what else to do here. Well, I'll be honest, for quotient rules, since obviously the answer you're going to get is a fraction because it's you know, it's right here, right? The formula involves a fraction. You can do some simplifying, and I may ask you, or I will ask you, I should say, to do some very basic simplifying from time to time. And I don't want anybody to get too freaked out and you know, do crazy things. But there's sometimes just some basic things that you can cancel or combine that would make it a little bit easy, make it a little cleaner, I guess, or make it look a little simpler. In particular, usually canceling stuff on the top and the bottom of a fraction is one of the most basic things we could do that would maybe just make this look a little bit nicer. So, and I just have, in the same breath that I say that, I also have to say this probably is the thing that gives people the most trouble, and it has nothing to do with calculus. It's just a straight up Algebra 1 issue. But what am I allowed to cancel? What am I not allowed to cancel? And I know this is, anyway, what is my best advice to you? If I don't ask you to simplify it, don't simplify it. So if I didn't ask you to simplify this problem, you should circle that thing I just wrote down and stop. But if I do ask you to simplify, what is it that I'm actually, all I'm going for is just that if there are things that legally cancel that actually make the problem simpler, do that. Okay, always show me steps though, because if you botch it, you should always write this down so far. And then if you botch it in the simplifying phase, at least I know, okay, well, you had most of it right. What can I cancel? Well, I'm going to scan this fraction here, and what is it I'm looking for? Well, the safest way to do cancellations with fractions that I know of anyway is to say if I'm about to cancel something from the top and the bottom, a safe thing to do would be to factor out whatever it is you're going to try to cancel. And then once it's factored out, you can sort of do what you all like to do, which is put a big slash through it. So I think, I don't know, I'm looking at this and I'm kind of seeing it, every term has an e to the x, right? You see one everywhere. So I kind of feel like I should maybe be able to cancel an e to the x out of this whole thing. So if I factor e to the x out of the top, let's see, what do I get? I get 2x's left from the first piece, and then minus x squared is left from the second piece. And I'm dividing by e to the x squared, which, remember, what is e to the x squared? Well, anything squared is just, you know, the thing times itself, right? X squared is just x times x. So e to the x squared is, well, e to the x times e to the x. So it is now that you can comfortably say to yourself, okay, so the top is e to the x times a thing, and the bottom is e to the x times a thing. So I can cancel one from each of them to say, okay, e to the x from the top and the bottom, that's just a fancy 1. And so what is it that I'm really only left with here is actually just this, which isn't actually all that terrible. And, you know, it's much nicer looking than what I had a few steps ago, right? So, okay, so basic canceling. Don't go crazy and try to, I don't know, do what else. Whatever else you think you might be able to do here, you don't have to do, because there's nothing else that's going to cancel here. So, in any case, if I'll ask you to do a little bit of simplifying, and again, only when I ask you to do it should you even attempt it. And if I do ask you, just do some basic things. And I promise if you either completely botch it or partially botch it, I won't, you know, it's not going to be completely wrong on an exam. I can still look through and see that you did most of it right. So, okay. So that's that one. Let me do one more, just so that I do one more. And actually, what I'm going to do for you here, so example 2, is the following. So let me do a trig one, a trig fraction. So sine of x over cosine of x. Now, I will just, well, there's a sort of a surprise, I guess, that's going to happen, I guess. But let me just say before we launch into this, sine of x over cosine of x, what are those guys? Remember from our trig review. Sine, so maybe don't write this down, but just sort of listen. So sine is what? opposite over hypotenuse, and cosine is adjacent over hypotenuse, right? Now, over hypotenuse for each of them cancels, right? If I divide both of them by the same thing, well, then I might as well have not divided it at all. So really, this is just opposite over adjacent. Oh, but wait a minute. Opposite over adjacent. That's tangent, right? So toa. So that's really just, so sine over cosine, while it looks like a fraction, and it is, it's a fraction, is actually just tangent. Same thing as tangent. Now, do I already know what the derivative of tangent is? Yes, it's in my chart, right? So I'll just remind us that actually from the chart, the derivative of tangent turns out to be secant squared. Remember, secant is 1 over cosine. So it's 1 over cosine squared, if you want to say that. So do I already know? I mean, this is like the world's worst example in many ways, because I already know what the answer to the question is. Sine over cosine, which is what I wrote down a minute ago, I think when I get finished with it, the answer should be that, or 1 over cosine squared, because the 1 over cosine is the same thing as secant. But let's pretend I didn't notice all that. I'm going to leave the answer kind of up there in the corner, and instead say, but wait a minute, okay, I'm not that bright. I didn't see that. So instead, what did I see when I looked at this problem? I saw what I think you saw, hopefully, when I wrote it down, which is that this looks like an example of the quotient rule, right? It's one fraction divided by another fraction. One function divided by another function. So this is screaming quotient rule at us, right? Just in the same way that x squared over e to the x, right? This hopefully screamed quotient rule. So let's do it with the quotient rule, right? So the quotient rule says I should get myself set up, and the quotient rule says I should identify the top of the fraction and the bottom of the fraction, which really couldn't be any easier, right? Sine and cosine, there they are. Top over bottom, yes, okay. And since I know I'm going to need them, I'm going to go ahead and write down the derivative of each of these guys. So the derivative of sine for my chart is cosine, and the derivative of cosine from my chart is negative sine. Those are both in our basic shortcut chart. Okay, so we have f and we have g, and we have f prime and we have g prime, so we have our 4 pieces. We're ready to assemble our answer, which is going to be hopefully the answer to what is the derivative of sine of x over cosine. All right, I'm going to just come below here instead. Sorry, usually I go to the right, but I have more space down there. So the derivative of this, again, via the quotient rule, right? And again, it's not a bad idea for you to identify for yourself, what rule am I using right now? Quotient rule. Okay. All right, so I got my pieces set up, so let's fill this in. So the quotient rule says the derivative of this should be g, so that's cosine, times f prime, which is also cosine, minus f, which is sine, times g prime, which is negative sine, all over the bottom squared. So that's cosine squared. Okay, so that's just the straight up the quotient rule from down here, from all my checks down here. I just did all those things again. All right, so that's that filled in. Now again, trig is maybe the only other time, and again, especially in a fraction, where you may have some canceling that you can do, or some simplifying. Now I'm going to pause, right, and say, I know that we cheated, or I cheated 5 minutes ago, and I said, you know what, I think I actually kind of expect the answer to be that. Because remember, I told you, or we saw, that sine of x over cosine of x is really just tangent. And our chart says the derivative of tangent is secant of x squared. So I'm hoping, I mean, my chart is a big lie, I guess, if that's wrong. And this, what I'm looking at right now, this awful fraction down here, I don't know, that sure as hell doesn't look like secant squared to me, does it? So there must be some combining and simplifying and things like that that I could maybe do that would, maybe help transform this. So when it comes to trig, sometimes you can combine stuff because you have something times something which just sort of collapses. In this case, what is it that I have? Well, I can try to do a little bit of simplifying here, and I can maybe say, well, that first term is what? Cosine times cosine. Okay, so that's cosine of x squared, right? Cosine times cosine, cosine squared. And the second piece over here on the right, sine. Now let's see here. I've got a negative sign, or I should say a negative sign, sign, right there, and another one there, right? So these are multiplied. So so two negatives make a positive, right? So I'm going to get plus, and then that's what? Sine times sine, which is the same thing as sine of x squared, right? Sine times sine. All divided by cosine of x squared. That's still there. All right. So, well, still don't quite have this, but now is where you have to dig a little bit deep, I guess, right? And say, well, the top of that fraction's cosine squared plus sine squared, and this is hopefully one that maybe your pre-calc teacher did a good job of burning into your brain. Cosine squared plus sine squared is 1. Okay, anytime you see cosine squared of x plus sine squared, or sine of x squared, anything like so cosine of anything squared plus the sine of the same thing squared, that's just 1. Okay, another way of thinking about it is that cosine is opposite, and cosine is adjacent, the adjacent side. Sine is the opposite side, and so when you add those together, you over the hypotenuse sides. I'm sorry. So when you get the adjacent side squared plus the opposite side squared, that's the hypotenuse side squared, which means when you'd add it up, you'd get hypotenuse over hypotenuse, which is 1. All right. It's okay if you didn't totally follow that, but it is true that the cosine of x squared plus the sine of x squared is actually just 1, as amazing as that might sound. So what I do actually have here is 1. The top is just 1 over cosine of x squared. Okay? Oh, but 1 over cosine is secant. That's just the definition of what secant is. So this is really secant of x. That's 1 over cosine squared. Okay, and so all is right with the world, and my chart was not a big fat lie. Indeed, the derivative of sine of x over cosine of x, aka tangent, is in fact secant of x squared. And I'll be honest, this is how they this is how they derived the derivative of tangent, was they didn't do some crazy formula or some f of x plus g. They didn't do that. They did this. They did the quotient rule. And in fact, you could derive the other trig derivatives, the cotangent and the secant and the cosecant, all by using the quotient rule. So I may ask you to do that maybe on an exam, but because they're just quotient rules. They're just examples of the quotient rule. So anyhow, this is just sort of a cute example where you can sort of see the quotient rule in action. But in any case, and this was also nice to see trig cancellation in case that comes up again. So, all right, so that's the quotient rule. I'm going to do one last example before the end of this video, which is going to serve to pull the two rules together. And by that I mean, what if you have a quotient and a product rule, right, all in one? So let me put one up here. So I guess this is example 3 in this list of examples. So what if you have more than one thing? What are you supposed to do about that? So let me say, what if we have something maybe like this? I don't want to do cosine. Sine of x over x times e to the x. Okay, so what is the first step, or what is the first thing we do? Look at it is the first step always. What is this? Is the first question you should ask yourself. Am I looking at, and look at, we've got this chart that's going for us. We've got, we know how to do the product of two functions. We know how to do the quotient of two functions. So what is this? Which one is that, I guess? And I'll be honest, looking at this, the answer is yes and yes. In other words, is this a quotient? Yes. Do I also see a product? Yes, I think. So it's clearly a quotient because it's a fraction, right? So I kind of feel the quotient rule is in my future. But also, look at the bottom of the fraction. That's x times e to the x. Well, that's a product of two functions, which if we've learned anything so far, hopefully, it's that if I have a product of two things, of two functions, I have a rule for that. I have a product rule. So in my attempt to be you guys for a minute, I would find myself at the very least, a little confused as to which rule do I maybe use first. I could sort of see wanting to do a quotient rule because I have a quotient, but maybe I also have the foresight to say, but wait a minute, that's a product. So do I do the product rule first? And then, well, okay, right. So I'm a little confused. So let me cure your confusion by giving you a way of always getting out of this jam. So when you think you need more than one rule, you should always choose a rule first. So what rule do you choose first is the answer to this question. If you think you need more than one rule in a problem, choose a rule first that uses the entire question. In other words, choose a rule that's going to involve sine of x divided by e to the x times e to the x. So if I had said, you know what, that looks like a product, it is the product, and I do need the product rule for that. If I had started my process by saying, and don't write this down, okay, I'm going to do the product rule on that. Well, I'm not going to say that that's wrong, but a problem that I have is that completely neglects the fact that it's sine of x divided by that thing. In other words, I've just sort of ignored sine of x. It's not a great idea to do. So my advice to you always is pick the rule first that uses everything. And then if you need another rule later on, use it when you need it. Okay? And that's super important. I am going to give you harder ones like these on the exam to be able to say, how do I deal with this? So I'm not going to do the product rule first because it would basically be ignoring the numerator. But if I do the quotient rule first, I think I'll just set this up just like I've set up the last couple ones. I'd say, okay, so who's the top and who's the bottom? So it's sine of x goes on top, and the bottom is x times e to the x. And don't be afraid that that's, is that in my chart? No. Sine of x, that's in my chart. But is x times e to x in my chart? No. But that's all right. I'm going to proceed. Okay? I'm going to do the quotient rule, so I know I need to know the derivative of each of these two characters, f and g, in order to be able to fill in the quotient rule. So let me write down the derivative of each piece. Okay? Well, the derivative of sine is cosine. That's in my chart. That's easy. And then g, I want the derivative of g. Oh. Well, now is when, the you who spotted this 5 minutes ago says, haha, I knew you needed the product rule because look, now you're stuck. Well, you're right, I am stuck. But, I'm not tragically stuck here, right? I'm saying, what is it, where am I right now? I'm saying, I'd like to know the derivative of that, x times e to the x. Well, I don't know what that is. It's true, I don't. And it's not in my chart. But am I completely hopeless? Am I completely doomed? No. I could compute the derivative of that. And for that, I might come off here to the side and say, pause. I'm going to pause this. And I'm going to come over here and I'm going to do a side problem, which is to say I need the product rule on x times e to the x. And I'm going to come off to the side in the margin or whatever and say I'm going to do a side problem and then return to my original problem in a minute. So I say, all right, I need to know the derivative of x times e to the x, and I don't know what that is. But I do recognize that that's a product of two functions, so I need the product rule. All right, so I'm going to come over here and I'm going to do the product rule on x times e to the x. So for the product rule over here, These are my f and my g, I think. Pretty easy. And these are both easy. These are both in my chart. The derivative of f is 1, and the derivative of g is just e to the x. So that's pretty simple. And the product rule says when I put my pieces together, I should get I should get f times the derivative of g, so that's f times the derivative of g, plus g times the derivative of f. So times 1, which is, I don't really need to write that down, right? It's just x e to the x plus e to the x. Okay, so I completed the product rule, and that's my result. Now, what do I do with that? Well, here's where, if you're kind of a good organizer on your paper, you'd say, well, why did I just do that? Well, it's because I needed the answer for right there, right? So if you kind of leave yourself a little flow chart almost of, I was trying to do this derivative, so I paused it and said, okay, wait, I got to come over here, do my problem. So my result of that problem should go back to wherever it was that I left. So that's what's going to fill in right here. Okay. Now, okay, it's very easy to get confused and say to yourself, well, what the hell am I doing right now? I've got all this stuff on my page. Well, I did the product rule, and that's done. Oh, wait a minute. I was doing the quotient rule 10 minutes ago, seemingly, when I got stuck. But I don't think I'm stuck anymore. The quotient rule, remember, it's hard to remember, right? But the whole original question was way the hell up there. That was a quotient, and I was trying to do the quotient rule, and I got stuck, but now I'm not stuck anymore. I know all 4 pieces for the quotient rule. They're all right here on the left. So I'm ready to actually complete the quotient rule, which will finally give me the answer to the question that I started with. So again, sorry, I'm coming down here to answer this question. So the derivative of this guy up here is from the quotient rule, which I'm finally ready to assemble. So the quotient rule, which is now right here, I can finally put all the pieces together for and see what we get. So I should get so for the quotient rule now, I'm using these guys right here. I'd get what? I'd get the bottom, g, times the derivative of the top, times cosine, minus the top, that's sine, times the derivative of the bottom, which is this whole thing. And don't forget, that's all divided by the bottom, which is g squared. Okay, so now that is an absolute disaster of an expression. So don't even, I mean, you know, don't even attempt to try to simplify that. There is very basic simplifying you could probably do, but let's not tempt fate here and even try to do anything. I'm just going to put a big box around it and say, that's my answer. And that is the correct answer. Now that's kind of I mean, this is a pretty awful expression, right? And again, in terms of, are things in nature modeled by something like this? No, probably not. So, but you know, just to sort of exercise these newfound rules, this is actually a pretty nice problem to be able to say this is kind of everything. You've got it all here. So, okay, this is about as bad as it would get, I think, for just a product and quotient, right? Is when you need them both. So let's hope that this doesn't happen too terribly often. But I would classify this as a hard problem, right? All right, so before I push stop on my video here, I should do what I always do at the end, which is to come back to the chart and fill in this newfound rule that we just did, which is the quotient rule, which says if you have one function divided by another function, then here's your answer. Should be the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. then parentheses. Okay, so quotient rule is a bit of a mess, I guess, right? It's a lot of pieces, but using it isn't really that hard. Is literally not any harder than the product rule. But there it is. So we've got now almost the complete story. We've got what happens if you have a coefficient, so a number in front. What happens if you've got the addition or subtraction of two or more functions? What happens if you want to multiply two functions? And what happens if you want to do the fraction or the division of two functions? Here's how you will handle all of these cases. And in reality, most things are combinations of these things. Maybe you need a product rule inside of a quotient rule, or maybe you need an addition rule inside of a product rule, whatever, right? These things can sort of be combined as needed. And again, armed with our master chart here on the left of all of our basic guys, you've got an awful lot here that you can do. The only thing missing will be the fifth and final, I promise, rule, which is to help us deal with something which is how do I process one function plugged into another function, or what you might have called in pre-calc class or algebra class, the composition of two functions. We need a rule for that, actually, because that happens quite often in modeling. So, but that's certainly for the next video, and then that is it. There are 5 rules and no more. So. All right, so that's the quotient rule, and again, we'll pick it up from here in the next video.